So this lesson for Foundations of Math 30 is covering 6.2, characteristics of equations of polynomial functions. So we're talking about characteristics. Now we talked a lot about a lot of characteristics already in 6.1, but here are some more characteristics that we're going to outline. And this is particularly for the equations. Okay, so yes, how the equations relate to the graph, but if we're looking at an equation, there's some things that you need to know about the equations that will help us as we move forward here. Okay? All right. So we've already talked about this kind of graph that has it's a straight line. What did we call that kind of function? Very good. Linear. That's awesome. And the standard form, okay, for a linear function is the slope y-intercept form, which is the one that you're very common, it's very common to you, you're very familiar with, and that's y equals mx plus b, but we're going to call it ax plus b. So we're going to use the letters a and b to define or to describe sort of the parameters of the line. So the slope will change as a changes. So you guys remember that? That this determines the slope of the line. If it's a very large positive number, then it's a very steep line, like this. If it's negative, so if a is negative, that means from left to right, it goes down. So kind of downhill left to right. And then if it's 0, that means that we have no x term. And it's just y equals some constant. And that would be a 0 slope like this, a horizontal line, which we talked about yesterday. Okay? What's b? Anybody remember what b is? b is this, right? Yeah, y-intercept. So here is the value for b, for this line right here. This would be the value of b for this line right here. So it's literally the y-intercept. Y-intercept. Oh, just a note, I do have your exams marked and graded. I'll return those back to you later. So do that later in the class. Somebody remind me 5 or 10 minutes to go. Give those back to you. Yeah, so that's linear, and this is standard form for linear. Now, there really isn't a definition so much for standard form. It's just kind of what it looks like, so how the equation is kind of arranged. So that's why we're just kind of, there's no real definition. For quadratic, okay, so if we have y equals, and remember the quadratic is the parabola, right? So if we have a parabola like this, the equation in standard form would be, again, we're going to use a x squared plus bx plus c. And you'll find this on page 384 if you're looking, it's the first page for the section. All right? And so you notice there's 3 terms. You notice that the x squared term is written first. Okay? Do any of you remember from previous math classes the quadratic formula? Do you remember that annoying little jingle that we used to memorize that?
Was it negative b plus or minus?
Yeah. Root. Yeah.
Square.
Yeah. That's right. I'm not sure if it's from. Did you guys learn it this year? Last semester, maybe? Last year, maybe? So the little jingle. Now, first of all, the quadratic formula helps us to find the roots, and the roots of a parabola or an equation, the roots represent the x-intercepts. So that may come later, and yes, there's an annoying little jingle like, what is it, the Pop Goes the Weasel or something. I think I made that up, yeah. I'm not sure if anyone else. Okay. X equals negative b plus or minus root b squared minus 4ac all over 2a. Just annoying enough for you to remember. Dun, 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 dun. Right? Okay. Good. You blocked it out. Okay. Well, that's not good. You don't want to block it out. Who said that? You don't want to block it out. You want to let it. You want to let it be annoying enough that it sticks in your brain. Your brain automatically blocks out annoying things. Okay. Is that why you can't remember your friends' names a lot of times? Okay. It is. Okay. Good. That was a dig to your friends, not to you. Okay. So that's the standard form. Now, Here's another important thing. A can't be 0, okay? A cannot be 0 because if A was 0, that means this whole term would be 0. It would be gone. And then you just end up with what? What would this be if it was just these two terms? It would be linear. See, it's the same as this, sort of the same format as this. So A can't be 0. That's the only thing. B could be 0, or C could be 0, as long as A isn't 0, because we have to have that x squared in order for it to be a quadratic. Okay? Yeah, and we'll explore this more as we go along. But let's just do... Yes. A determines a couple things. A determines which way the parabola opens up. If A is positive, that's greater than 0, okay, then the parabola opens upward. Yeah, very good for remembering that. And if A is negative, less than 0, it opens downward. Yes, very, very true. Do you remember what else about the size of A and how that affects the parabola? Yeah. Okay, yeah. If A is greater than 1, it sort of gets narrow, yeah. And the larger the number is, the narrower it is, yeah. And then if it's, what makes it wider then? Is it negative values that make it wider? It's under 1. So like half. Okay, good. Good. Or more specifically, if A itself, the number itself, just the not the sign, but if it's between 0 and 1, right? Or between 0 and negative 1 if it's opening downward. But yeah, if it's a fraction. So if A is between, negative 1 and 1, so if it's a fraction like that, then it's a wide parabola. And if A is greater than 1, or less than negative 1, right? If the actual number for A is large, 2, 3, 4, 5, 100 million, then it's really narrow. Okay? Like my counting? Yeah, 500 million. Okay? All right, so just real quickly, cubic then. The cubic functions. Cubic functions. So we have, now who remembers this notation here? Because they actually have this in the book. I've just been doing y. But you can do f of x. Do you remember what this kind of notation is? Well, it's the same as y. Yeah. Maybe Heather knows. Heather? 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 Hi. Heather? Hi. She was having a dream. It's cute. Do you know what notation this is right here? Do you recognize this? The name for it starts with F. Function notation. Yes, very good. Function notation. Okay, it's called function notation. So basically it means that whatever is being described over here is a function with this variable included. It's a function of x. Now we could have relations that aren't functions, right? And we talked about those graphs the other day where they, a graph that goes like this. Okay, that could be a relation, some kind of strange relation between these two variables, but it's not a function. That means that one side is not strictly described in terms of only one variable on this side. Okay? Anyways, I won't go too far into that. That's for another class. But anyways, it's function notation. And for cubic, it looks like this. Of course, we would have ax, and what am I going to put up here? Yeah, a 3 for cubed. Very good. Plus bx squared. So now we work down. See, the degree is 3. The next term would be the x squared. And then it's a, b, c, x to the 1, plus d. Okay, that's the general format. Now you might be wondering, I'm going to erase this. It doesn't look like it's part of that. You may be wondering, how come there's only pluses in here? I look at all of these formats. All I see is pluses. I don't know if anyone's thought of that yet. No? Okay, that's fine. Only us teachers notice really neat things like that. It's really special. Anyways, you can have negative signs there, or subtractions, no problem. It just means that in this case, the b would be negative. So it would be like adding a negative. If b was negative 2, this would show up as something x cubed minus 2x squared, and so on. So yeah, you can have minuses there. If you look at this cubic, equation, you say, oh, there's a minus in there. It's not a cubic, it's not in standard form, or it's not, this is wrong. It's okay. It's okay to have plus or minus in there, right? Okay, you'll be able to sleep better now at night? Good. Okay, this is good. I know, some of you are sleeping well now. Okay. All right. What else do we need to know? Oh, let's talk about the leading coefficient. What is the leading coefficient? You've heard of lead actors and leading parts. Has nothing to do with that. Okay, the leading coefficient. Okay, but it is sort of the same. If you think of the leading lady in the play, do we have any leading ladies in the play here? Scott? Yeah? No, sorry. Hannah? Are you the leading lady in the play? Okay. What is this? Mary Poppins we're doing this year? Okay, so you're Mary? What's your last name in the play? Oh, Poppins, right. I knew that. I knew that. Mr. Popper. Anyways, so leading now, so she would be sort of at the top of the list of all the actors, right? Is that true? Is that the way it goes in the program? Kind of at the front. And she's on the stage at the front, being an overactor, more than anyone else, right? Glad you're not Miss Hannigan this year, drinking publicly on stage, Christian school. Your floozy little flimsy outfit. Okay, anyways, it was great. Well, it was a flimsy outfit. Anyways, I digress. It was perfect for the part, okay? Hey, okay, anyway, I won't talk to you. It was great, and I'm sure it'll be great again. But listen, I'm saying this for a purpose, okay? Here's the purpose. Leading, okay, the leading coefficient, leading, Scott, means it's coming first. And the coefficient is the number. So it's the first number in the standard form. The leading coefficient. Here it's A. And it's A in all the other standard forms as well. So if I said, or wrote down this right here, okay? 2x squared plus 3x minus 1. Okay, I have a few questions for you now. What kind of equation is this? Is this linear? Is it quadratic? Is it cubic? What is it? Okay, I heard a faint quadratic answer back there. Yes, you're right. It's quadratic. It's a parabola. Why? Because you look at the variables and you look at the exponents on those variables and you say, what's the largest one that I see here? And it's 2, and so that means it's degree 2, which is, thank you, a quadratic equation. Okay, very good. It's quadratic. Now, what's the leading coefficient in this equation? 2, right here. This one right here. Why? It's the leading lady here in this play. All right, right up front. Name is listed in the program. Right, first. Okay, she's up there drinking on stage. All right, right there at the very beginning. I'm just joking. Now, the leading coefficient is actually going to be quite important as we move forward. Okay, in describing sort of how these graphs behave, how they look. So you're going to be able to look at the equation, and you're going to say, right now you already know a couple things. You know that this is a quadratic equation, therefore it's a parabola shape. And you know that now the leading coefficient is a positive 2, which we actually talked about a few minutes ago, right? Here's A, the leading coefficient. If it's positive, it opens up. So look at this lesson. It's all about characteristics of these equations. You know so much already. Quadratic equation, parabola, positive leading coefficient, opens upward. Is it narrower or wider than normal? Narrower, because this is greater than 1. See? You guys know so much already. You and this equation really first name basis. Right there. Yeah, you can call it Quaddy. Hey Quaddy. Hey Quaddy.
Okay, I have a question.
Hey Quaddy, you wanna hang out at my place? No, actually I open upward. I don't hang. Anyways. Well, it opens upward. It doesn't hang. See, this one would be able to hang out at your place. So now Quaddy can hang out at your place. Okay? All right. That's my story. Wait! Are you serious? That is so lame. Open the window. I'm going to jump out. Is that what you said?
Yeah.
That is totally inappropriate. I just want. Do you need counseling? Actually, you do need counseling, but I'm not sure for what. Okay, you have an actual question?
Yeah.
Okay, I'll acknowledge your hand.
Okay, in cubic, if A.
I was going to hand. That's a very good question. And I was going to hand you all